Thank you all for being here. Thank you for letting me speak today. My name's Stephanie Kim. I'm going to talk about investigating user experience with natural language analysis. So this talk focuses on the methodology and intent of studying feedback form and other user messaging data with R tools and libraries for natural language processing and machine learning. So I'll discuss potential trouble areas of starting such a project from scratch from a developer's perspective. So shocker, I'm a developer. But I also do some data science work, and it's usually on doing natural language processing. So I love to help people build better products by learning what users are thinking and trying to understand how they're feeling using machine learning and text analysis. So in 2012, I believe it was, I founded the Seattle Pie Ladies location. And currently, I'm a developer, advocate, and software engineer at Algorithmia. And I also spend a lot of my time increasing my own knowledge and educating others on racial bias in AI. So shameless plug, if you're going to be around for O'Reilly AI, I think it's like next week I'm going to be back, or ODSC East in Boston, come check out my racial bias talk. It's a really important subject, so I'd love to see any of you there. So just a quick blurb about the guys who pay the bills. So at Algorithmia, we believe that every application will eventually become an intelligent application, but as my boss and CTO, Kenny Daniels, said, TensorFlow is open source, scaling it's not. So on our platform, data scientists and enterprise customers can productionize their models in minutes and turn them into scalable REST API endpoints, and they can privatize, open source, or even monetize their models for other developers to call on our open marketplace. So at the end of the talk, there'll be a promo code. If you want to try us out, I'll give you some free credits. So now let's get to the good stuff. So again, this talk will cover the benefits of investigating your user data. We'll talk about the types of helpful techniques that are commonly used in this kind of analysis. And I'll talk about what to do when the model's not performing very well. And then what to do with the insights that you gain. So why investigate user feedback? We read user messages that come in, whether you're using feedback form vendors such as 4C or user messaging data vendor like Intercom. Often we read these messages when we have time, but we don't get to look at overall trends. So users have some really important insights and suggestions for making your product better. So it's really important to know what they're talking about. So the goal is to increase your awareness of what users are thinking and feeling from a high-level view. As I mentioned, you want to look at those trends, but then you want to get those messages to the appropriate teams so you can help your users be happier and more successful using your product. So by analyzing feedback, you can find hidden trends and patterns, doing sentiment or even topic-based time series analysis. You can find bugs and design issues that might have been missed in QA by doing anomaly detection. You can even gain new opportunities to run A/B tests based off user feedback. Prioritize user messages based off of topic or sentiment, and then respond accordingly. And then you can also learn about, as I said, feature requests or needs from the users. They're the ones using it the most. They're the ones that it might be failing on. So you can also do segmentation and targeted messaging. For instance, you can identify all the unhappy customers or people who asked for certain features and reach out to them specifically if you have non-anonymous data. So that's a lot of stuff that you could do with user messaging and feedback form data. So about that data. User feedback form data is notoriously dirty, like disgustingly dirty. Some more than others. Intercom data is the worst that I've touched. 4C feedback form data is actually not too bad. So you're going to be looking at having to strip out HTML tags, grammatical errors. Now some things that you might want to take out for document classification, but you might want to keep for sentiment classification are things like swear words and emoticon-like text, which you'd want to transform into some kind of token a sentiment classifier would pick up. So note that for these slides, they're based on Intercom data, which we use at Algorithmia. And in the past, at Apollo Education Group, I've used 4C feedback form data. So you also want to make sure you create your custom stop word lists. And I like to ignore super short comments that contain less than some threshold of tokens. I usually pick 3 tokens once all the stop words are taken out. So I love this. Isn't insightful data for information retrieval purposes, but it can be insightful for sentiment scores, especially if you know, like say you're running an A/B test and you know exactly, what form was changed in a certain way, then that sentiment might be useful. So make sure you keep your goals in mind when you're cleaning your data. So of course, you'd also want to use a stemmer or a lematizer, and you'd want to increase sparsity with rs remove sparse words, or if you're in Python, you might use count vectorizer to help develop more meaningful clusters in your data and decrease the chance of creating a model that overfits to your data. So, oh, and by the way, I didn't mention, so I said I'm a developer. I actually do Python and R. I have been using R more and more lately, so don't tell the Py ladies. Shh. So let's first address what y'all probably already know about performance, that when performance is your top priority and you're working with large data sets, you want to use data.table, which scales better than data frames. So this is because data frames make a deep copy, and that means that it copies the entire data frame to another location in memory, and so it clogs down your machine. And when you're working with really large data sets, that could mean a long wait of doing nothing but staring at your laptop process R, which is not that fun. So when performance isn't your top priority, because a lot of us actually don't work with big data, you might want to use dplyr for its readability, flexibility, and that nice abstracted data layer when you need to connect to different data sources. I'm a big fan of dplyr syntax. I use it a lot. Regardless, you should use data table's fread function versus read CSV when consuming static data files, because read CSV is super slow. You've got a major win on speed using fread. So if you're dealing with data that when you're dealing with larger data sets, you'll want to use fread because it imports the data immediately as characters, whereas read CSV first tries to convert the data into integers and factors and all this other stuff, and you're waiting a little bit longer. You also might want to try, this is not a package I've tried yet, but I'm really curious about playing around with it. It's Microsoft ROpen library, which is Microsoft's re-release of Revolution Analytics ROpen. It's a company who Microsoft acquired a while back. So Microsoft ROpen has a package, that package allows for multi-threaded capabilities that speed up common matrix operations by quite a bit by using all cores through parallel processing. Now, you will have to depend on Intel's math kernel library to take advantage of it, so it's another dependency, to think about. And they also have, I believe, paid libraries as well that are even faster. Again, I haven't checked out any of those, but it's kind of on my to-do list. So now that we've covered what you should think about as far as libraries and your data before you get started analyzing, let's talk about the types of analysis that might be helpful. So, when you're thinking about investigating your user data, you'll probably start with some basic text mining techniques in order to find patterns in your data. So you'll be doing some unsupervised clustering, such as k-means or dendrograms, or use topic modeling with LDA. And then you'll likely want to move to sentiment analysis, document classification, or even time series or anomaly detection. As I go along, we'll cover what models you would use for these different types of use cases and the insights you can gain from them. So first, you might want to find hidden patterns or topics in your data. So you can use different unsupervised techniques, such as in this slide, there's a k-means clustering that's used, but I actually kind of prefer dendrograms. They're just a little bit harder to see on the screen. You could do word clouds, named, entity recognition, and more. So on the upper left, there's a cluster with the terms air, image, colorize, which I'll talk about later. But I want to point out that a lot of these unsupervised techniques, the ones that I mentioned, probably are going to produce similar results because many of them use Euclidean distance. So they'll give you similar clusters, but different visualizations. So it's probably not worth your time to create all of them for one analysis. So choose the one that best fits your goal. Not that I've spent time creating like every visualization or anything. No, I wouldn't do that. For instance, if you're generating reports, then maybe choose one with a nice visualization. Like I said, I like dendrograms. That way you could see the hierarchy of clustered words that often appear together. But say you're prepping for document classification, then you're gonna probably wanna skip this and just go to LDA to get your documents by topics. So again, keep those goals in mind so you don't waste time going down a rabbit hole. So if you want to satisfy your own curiosity about what users are thinking about the most and give your place to start when thinking about document classification or other information retrieval tasks, such as creating the topic labels for LDA, you can use a term frequency chart. So you'll probably want to use bigrams versus unigrams or trigrams, but test with your own data to see what works the best for you. I've done this project, I think, 3 times at 2 different companies, and I've consistently found bigrams to work the best for this type of data. So this bigram frequency is using TF-IDF. Don't think I need to describe what that is, but in case, it's a statistic that measures the relative importance of an n-gram to the whole document. So in our case, the 5 top terms are machine learning, sentiment analysis, deep learning, error message, and API key. Again, that error message, just that bigram keeps popping up. So, but we want to do LDA, and LDA requires bag of words. So you can see the top bigrams change a little bit. So if you're doing document classification, but your user messages aren't labeled with topics yet, yeah, I love all these LDA and document classification tutorials. The document classification tutorials always assume you have labeled data, but a lot of times that's not true. So you can use LDA, which is a topic modeler that discovers topics and documents and assigns probabilities to those terms, making up the topics. So notice on our slide, we have terms that make up a topic, and behind the scenes, they have probabilities assigned to them that indicate how well they fit into that grouping. But note that we don't have any labels for our topics yet. So looking at topic 3, we could possibly infer that it's about people asking questions regarding deploying their model to Algorithmia, while topic 4 might be about problems on how to use the Python client. Pythons are probably our most popular language on the marketplace. I would say R is probably the most popular on the enterprise side. So going back to the term frequency chart, we might decide to call topic 4 error message, or we could be more specific and call it Python error message. So these results came from the topic models package from tidytext, which uses Gibbs sampling. But note that there are a lot of other LDA models available in R, such as text-to-vec and the mallet package. And I think, I haven't tried the text-to-vec package, but mallet tends to give pretty good results. So LDA is so easy to implement on your data. You should definitely test these all out to see what gives you the best results. But I want to make a note that text-to-vec is likely going to be the most performant because it's based on warp LDA, which is memory efficient. So after you've done your LDA, you need to map your documents to their associated topics. So again, before we just had the topics, but we need to create the labels for those too. This document had 60% probability of belonging in this topic. It was probably, LDA called it topic 4 or something like that, which I decided to call client API errors. So node client option request server response CORS error would have the label client API errors. And that label I made up based off of my domain knowledge. I then use these mappings to create a training set for document classification since I don't already have a labeled data set. So the end goal here is that you have your topics and they're mapped to documents, and now you can do some investigation into the UI and find out areas that users might be having trouble with. So at my previous job at Apollo Education Group, I found that people were having trouble using a confusing dropdown, and so it wasn't actually a bug, it was a UI issue. So also at Algorithmia, after manually reading the documents that map to the topics found in the previous slide, I revisited our Python docs, client docs, and our model hosting docs. And I decided to just make them a little bit clearer for beginners, do a little bit more hand-holding in the documentation. So, and now that you have these labeled documents, again, you can train the model for document classification. Speaking of which, now we'll go through some types of models you might want to try for classification tasks. So whether you're training a document or a sentiment classification model, most models' accuracy and performance depends upon how many classes you're trying to classify on and how large of a data set you have access to. So more classes require more data, which is really important when you're looking at document classification. You don't want to have too many classes. So here are some broad guidelines, but again, you really have to test your own data on various models to see what will work best on your data set. So many people's go-tos, naive Bayes, especially if you don't have a ton of data. But if you have some more data and you want a more robust model, you could try random forest. But note that choosing random forest will give you most likely a boost in accuracy, but you'll lose speed, which is really important in real-world applications if you're productionizing your model. So usually naive Bayes is good enough for the real world. So for decent accuracy, but kind of a lack of scalability because of word embeddings are a little slow, you might want to try word-to-vec via word vectors package in R, text-to-vec, which I already mentioned, which is similar to Python's doc-to-vec, or even LDA-to-vec, which combines word-to-vec word embeddings with LDA's topic modeling. I'm really curious to use that one. I haven't played around with it yet, but that's another on my to-do list. So when you don't have enough data to train your model, especially like if you only have maybe a year's worth or less of user messaging data, don't discard the many pre-trained sentiment models out there. R has some, and there are other open source sentiment pre-trained models out there. So feedback form data is fairly similar to social data. So it has a lot of misspelled words, fragmented sentences, emoticon slang, et cetera. So it's useful to check out pre-trained models if you don't have enough data to train your own. So lastly, if you have the infrastructure available for GPUs and you have a lot of data for each class and time is on your side for training, then you can use deep learning. I wouldn't suggest like that being your starting point, but you could try convolutional neural nets for classification tasks. And that way you won't have to focus on feature engineering and you should get pretty good results, but that's not always the case. So definitely not the place to start out with. So make sure you understand your priorities. Are you looking for performance or are you looking for accuracy? And base decisions on your data size and your available infrastructure. All right, so one of the most useful analysis you can do on user data is to discover how user sentiment changes over time. So you're looking at your message data on a daily basis, but it's really hard to see trends. So, but even more insightful is when you integrate release dates as benchmarks in order to gauge sentiment changes. So say you have a major design release or maybe even a demo of when your APIs were released in the wild and you want to find out how users felt about it, a little foreshadowing there. So notice the spike in negative sentiment. It has to do with that cluster we found in the k-mean slide, that bigram error message, but honestly, I'm still too traumatized to talk about it. So depending on the vendor, I already mentioned a couple of vendors that people use for collecting user message data. You might be lucky enough to have the URI that the forum or comment was made on. That way you can aggregate sentiment by pages. So for example, if you want to find the sentiment scores for a landing page, you can run, and you're running A/B tests on different styles, you can gain extra insight beyond conversion rates and pull out the negative comments to see what issues users were having with that style. But I want to mention again here that while we're looking at the overall trends, we're then drilling down with a more narrowed scope to view our highest priority areas. And then we're checking those messages manually and responding accordingly, because machine learning and automation only goes so far in understanding what users are thinking and how they're feeling. So besides sentiment, you could do a time series analysis on topics. So I'm finally ready to talk about what happened in mid-2017 to get such somber clusters in sentiment. So this slide shows a huge spike that occurred for the bigram error message. And this was due to a demo we created for our colorizer algorithm that developers could use in their apps to colorize their black and white photos via our API. So the reason we're getting so many user messages that contain the bigram error message and such negative sentiments in our user messaging was that the demo landed on a few genealogy and photography sites. And non-developers were sending us messages that they were having difficulties uploading their black and white images to our demo. They thought this was like just software that they could use to, and it was just a simple demo to show how easy it was to, call the colorizer algorithm via our API. So at the time, we found these messages manually, but if you have a live data stream and are building out really cool real-time dashboards, you might want to track a few important n-grams that you can either get from the frequency chart that we looked at or the topics from a topic modeler like LDA. And that way you can get a feel of what users are talking about and set up alerts to notify if it's over or under a certain threshold for anomaly detection. So you could see even with this completely unexpected example, it's really helpful to track what users are talking about in real time so that you can help them use your app, your API, or in this case, redirect them to an iOS app to colorize their black and white photos when they aren't your target user. So if you want to do time series to understand the overall trends in your data and even forecast future trends and topics or sentiment, you might want to try some of the models shown on the slide. I'm not going to go into details, but a quick CAP, autoregressive integrated moving average is kind of my go-to. It's the one I know best. So I usually do that for some quick forecasting. And then on the slide for sentiment analysis, I believe I use Holt-Winters, which is a triple exponential smoothing model. So a couple of weeks ago, actually, I was doing some Google searches on stuff, and I came across Profit, which there was an awesome talk about yesterday. So I did a really quick proof of concept. It's super easy to get up and running with that. Unfortunately, it kept crashing R when I tried to plot it. So I've got some debugging work to do to figure that out. But it's super user-friendly, really fast to get up and running. So I suggest checking that out. If you're looking to detect anomalies, such as our colorizer spike, you could use a support vector machine algorithm or k-nearest neighbor. Twitter has also put out a promising anomaly detection model that's available for R called anomaly detection. I haven't played around with that one yet, but I've heard good things, so definitely another one to check out. So, and of course I have to talk about one of our algorithm developers just put out a generative forecasting model called generative forecast and anomaly detection model called threshold anomaly detection. I haven't checked out either. I'm going to be honest about that, but he's a pretty talented guy, so you might want to look at those too. So, and of course, if you have a ton of data, and again, you have the infrastructure to train your model, you might want to look at a RNN variant, long short-term memory model, which has really good results for anomaly detection and other classification problems. And that's due to LSTM's ability to recall older information from previous passes in the network that other neural nets don't include. So with time series anomaly detection, you can detect and then prioritize your groups of users that have problems using your product or site, and then respond to them quickly and triage the issue to the appropriate team lead. So sometimes your model is not performing. How am I doing on time? Oh, way over. I'm so sorry. OK. So, OK, we're done. That's OK. I'll post these slides up somewhere. So here, you could take a picture of the promo code if you want to check us out. Thank you so much for having me. Sorry, I went over.